Hi, my name is Devin Murray, one of the applications engineers here at Schmersal, USA, and today we are taking a look at our latest switch, the AZM300. So what is it and what can it do? The AZM300 is a safety interlock switch with a guard lock-in. It is based off the RFID operating principle, and it will include dual microprocessors for self-monitoring, self-diagnostics. That means that it can achieve performance level E, so level 3 with just one switch, or other AZM300s wired in series. And you can still maintain that high level, still level 3 performance level E when you have the AZM300 wired in series with other RFID devices from Schmersal and or other pulse cycle devices from Schmersal wired in series. It is a guard lock-in switch, so there is that high 1,000 newtons of holding force, which is roughly about 225 pounds. There's also an easy adjustable latching force that is adjusted simply by turning the locking mechanism, and that can be either 25 or 50 newtons, which is roughly about 6.5 pounds to 11 pounds. The AZM300 is IP69K rated, which means it can be used in high pressure, high temperature washdown applications, and it is also Ecolab approved, which means that it is resistant against a wide range of cleaning agents. The AZM300, just like the other Schmersal RFID and pulse echo devices, will feature two safe PNP outputs as well as a diagnostic output. And it will feature the LEDs directly at the switch, so you can have an indication of the status of the AZM300 directly at the door, whether you have power, if the door is open or locked, and if you have any errors. When we look at the actuator of the AZM300, we see that this switch is made for symmetrical mounting, so you don't have to worry about ordering a left or right hand version. The locking portion of the actuator in this switch, you can see there is a nice wide range of actuator tolerance. And the actuator itself will feature door detection sensors. So the AZM300 is looking to make sure that the door is closed or that the actuator is present and that the rotary locking mechanism has turned before you can get your safety outputs. That way, an operator cannot simply go to the door and turn the mechanism, the locking mechanism. The AZM300 is looking for the actuator in these door detection sensors. Some of the options for the AZM300, again, includes the standard version where the AZM300 is looking for the door to be closed and not lock signal before you get your safety outputs. And we offer that with the power to lock and the power to unlock. We also have the B variant with AZM300B, where the AZM300 is looking for the door to be closed and that it can be locked. So it's not looking for the lock signal before you have your safety outputs. As long as the door is closed and there aren't any faults and the lock signal can be delivered, you will have 24 volts delivered at your output, and that's more for the process industry. We also have, for both the AZM300 and the 300B, we have the standard diagnostics, which is the 24 volt signal saying that the door is open or closed. And we also have the option for serial diagnostics, and that will give you more detailed information about the status of the AZM300, such as if the temperature is too high, if you have any faults on your safety outputs, if there's damage to the actuator, if there is a incorrect position with your rotary handle. Numerous errors can be relayed over over a network using different protocols such as Ethernet IP, Profibus, DeviceNet, just to name a few. Another option for the AZM300 will be for an increased tamper-proof environment. So if you have the need where you have to have an individually coded key, we offer that with the I2 version. Now with that, you take the AZM300 and a individually coded actuator and teach it in to the AZM300, and only that actuator would be able to deliver the 24 volts for your safety outputs. And if you happen to damage or lose that actuator, you throw it away, order another individually coded actuator and teach that in with the AZM300. There's also another option for an even more increased tamper-proof environments where you can only teach in one actuator to the AZM300, and that's with the I1 option. And if for some reason the actuator is damaged or it gets lost, you have to replace both the AZM300 and the actuator. When we look at the AZM300, one of the first things you may notice is the actual locking mechanism itself. This is made out of glass fiber reinforced plastic. That has the similar mechanical properties as cast metal, but we do not use cast metal because glass fiber reinforced plastic is more elastic, which means what makes it more better for actuator impact because the AZM300 can be used as an end stop. So these are some of the features of the AZM300. Let's take a look at it mounted and some more features once we actually apply power to it. So here is the AZM300 mounted on a demo gate, and if we take a closer look at it, we see that it is an M12 8-pole connector. We see that we have a emergency solenoid bypass latch on the switch. And we'll also notice those LEDs for a quick diagnostics directly at the door itself. So you know if you have power at the switch, the status of the switch, whether the door is closed, if it's closed and locked, or if it's open, and also the various fault codes that you get. And go ahead and open the door and take a look at the actuator. And you'll notice that it has a nice wide loop actuator that goes on that star grip. So you have a high range of actuator tolerance. You'll also notice the dampener on here, and that's because again the AZM300 can be used as an end stop. The door is flush mount with the frame, so there is the option of ordering this mounting plate here, which extends the AZM300 so it can be even with the actuator once the door is closed. And there is the locking mechanism. So this is the AZM300 mounted. Let's go ahead and apply some power to it. What we have here is an active demo showing the AZM300 and its functions. What we're going to use to control the demo is this BDF200 control station. There's a nice YouTube video on this. It's a Schmersal product, and it's a nice control station where it is fully configurable for your application needs. One thing I like to point out for the AZM300, as you can see, it is actuators mounted on a plexiglass door. We offer this as an option. This is a mounting bracket for the actuator, and as you can see, when you use it, you can maintain your nice clean look on your machine. So we offer this as an option to conceal the screws when you mount the actuator to a plexiglass door. Now, there have been studies on guard locking switches that have not been mounted or installed correctly and how that can damage the locking mechanism. For guard locking switches, whether it's electrical, mechanical, or microprocessor based, as soon as you send a lock signal to the switch, it's simply waiting for that actuator to be present in order for it to lock. So if you have a heavy door, for example, that's can have a bounce back to it, and you send the lock signal to your guard locking switch and you slam the door and that heavy door bounces back, the switch is going to be locked. The actuator is going to be locked in the switch, but you are now adding stress to the cams. Over time, again, if your guard locking switch is not mounted or installed correctly, this can cause damage to the locking mechanism. The AZM300 is a guard locking switch, but we have addressed this issue by having a brief 200 millisecond delay on the locking mechanism. So let's first show you how we would lock the AZM300. So we would simply close the door, and you see that when the door is closed, we have diagnostic output saying the door is closed. And if we send out a lock signal, we see that we have active outputs. So our two PNP 24 volt outputs have become active. And if we unlock the door, our outputs drop out. We still have our diagnostic outputs saying that the door is closed. And when we open the door, our diagnostics turn off. So going back to the idea of how you can damage the locking mechanism for solenoid switches. So let's go ahead and send our lock signal. In conventional devices, as soon as you close the door, the switch will lock. And again, if you have a heavy door with bounce back and the switch is not mounted or installed correctly, you can have the possibility of damaging the CAN mechanism over time. So now we have our lock signal to our AZM300, and let's say this is a big door with the possibility of a bounce back. Notice that the AZM300 has a short 200 millisecond delay, which allows the door to bounce back open, so we're not adding stress to the locking mechanism. And as soon as the door is closed, you have your safety outputs because we already applied the signal for locking. So that brief 200 millisecond delay allows you to maintain the integrity of your locking mechanism even if you have a large door with bounce back. Thank you for taking the time to watch this YouTube video. Don't forget to look at the website for more information such as the brochure, CAD files, mounting and wiring instructions. And if you have any questions, feel free to send us an email or give us a call.